Hello and welcome back to Machine Learning. I'm Jovita Christie, and in this video, we are going to talk about different machine learning activities that you can do to prepare your data, and also about different types of data that are available in machine learning. So let's begin. What you see here is the process of machine learning. So this is the process. You first have your data, which is given to you, and the first step you will do is to prepare to model. Because before you apply your machine learning model, you have to do a lot of cleaning and organizing of your data in order to be able to perform machine learning. So this is the prepare to model part. Once you've done that, then you will go to the learning part where you will actually apply some algorithm, machine learning algorithm to learn. Once that is done, you will measure the performance of your model by using some accuracy measures. You could use a confusion matrix or something of that sort to measure the performance. And if the performance is not up to the mark, you could improve the performance by adjusting some of the parameters that you used while performing the learning step. So these are the steps. And if you have followed along the videos that we did so far, you probably understood how to do this learning part, how to do the evaluation part or improvement part, but you haven't learned yet how to do the modeling part, how to prepare the data for modeling. So we are going to see that part now in this video and several of the upcoming videos. And let's also take a look at the different kinds of activities you can do for each of these steps. So the first step is to prepare to model. In this, you have to, first of all, understand the types of data that are available in your data set. And this is what we will see in this video. We will see what kinds of data can be available in a machine learning project. You also have to understand the quality of your data. You have to understand what relationships those elements have among themselves. For example, height and weight are related to each other, so that could help you later. You also have to find potential issues in your data, like there could be some missing values, incorrect values, some values which are not in proper format. So all these problems can be there. And you have to remediate those problems, which is your next step. You have to solve all those problems. You can also do these pre-processing steps if necessary to reduce the size of your data set, not by reducing the number of rows, but by reducing the number of columns, because you may not need to use all the columns to perform your machine learning. So some of the columns might be useless. So you might have to remove them, and you can remove such columns using dimensionality reduction and feature subset selection. I have previously given a brief overview of these things, but we will be seeing them in detail later on with programs. The next step is the learning step, where what you should do is partitioning, right? You partition your data into test and training. You will select what model suits best for your algorithm, for your data. You will also do cross-validation. So you will be studying cross-validation as well later. Step 3, you can measure the performance of your model. You can do that using a confusion matrix if it is classification, using some accuracy metric if like R-square or mean squared error if it is regression. And you can also visualize these things using graphs. And the final step is performance improvement. So once your model is ready and you're not getting the desired accuracy or performance, then you can improvise it by fine-tuning the model, by performing ensembling, by bagging or boosting. These are some of the performance improvement techniques we will be seeing later. Now let's take a look at different types of data that are available in machine learning. So this would help you to better understand your data set and apply all your algorithms. So first kind of data is the qualitative data, which provides information about the quality of an object or information which cannot be measured. Okay. For example, It could be something like performance of students in terms of good, average, poor. This is not measured. It falls into sort of a categorical data instead of giving percentage. Also, somebody's name or roll number. Okay, they are also information that cannot be measured using some scale. So these two are qualitative data. They would all fall under the qualitative data category. So qualitative data is sometimes also called categorical data. It can be divided into two more types, which are nominal and ordinal data. Let's take a look at nominal data. So nominal data is one which has no numeric value, but it has a named value, okay? And it is used for assigning named values to attributes. Nominal values cannot be quantified because they are qualitative and because they have some named values which are assigned to the attributes. Let's see some examples. So you can have blood group, which cannot be quantified. It is qualitative, A, B, O, A, B. Those are all blood groups. People's nationalities like Indian, American, British, those are also nominal data. Gender like male, female, other, they are all nominal data. And it is obvious that if you want to apply all the mathematical operations like addition, subtraction, multiplication, you cannot do that on nominal data because they are not numbers. Also, statistical functions like mean, variance, standard deviations also cannot be applied on the nominal data because they don't have any numbers. But you can perform count. You can perform count. You can count how many people with O blood group type or A blood group type are there. Okay. Mode can also be identified. Okay. How many times O blood group is coming? How many times A is coming? So which is the most frequently occurring blood group? So you can apply mode, you can apply count, but you cannot apply mean and variance to nominal data. Let's talk about ordinal data. So in ordinal data, in addition to possessing all the properties of nominal data, you can also order them. That's why they are called ordinal. Okay. So this means it assigns named values to attributes, but unlike nominal data, you can arrange these in a sequence of increasing or decreasing values. Okay, so you could say that one value is better than another value. So that is that ordinal data. Okay. So examples of this would be customer satisfaction, like very happy or just happy or unhappy. You could arrange this and you could say that very happy is better than just being happy. Also grades like A, B, C, where you can say that getting a grade A is better than getting a grade B. Also hardness of metal, like very hard, just hard or soft. And like nominal data, you can perform basic counting for these ordinal data. And so the mode also can be identified. You can find out which of these categories is appearing the most number of times. So you can do counting, you can do mode on this type of data. And because ordering is possible, you could also be able to identify the median or the quartiles in this kind of data. But mean cannot still be calculated because there is no value available to add and then divide. So mean is not possible. The next type of data we have is the qualitative data. We know that quantitative data relates to we already saw qualitative data. Now we are going to see the quantitative data type, which relates to information about the quantity of an object. So it can be measured. It's not just about quality, it's about quantity, so it can be measured. For example, if we consider the attribute marks, it would be quantitative because you could use a scale of measurement and measure somebody's marks. And it is sometimes also called numeric data. And there are two types of quantitative data. First, you have interval data, and you also have ratio data. Okay, so quantitative data is data like marks. Marks is quantitative. Somebody's height can be quantitative. Weight can be quantitative. But if you talk about eye colors or hair color or somebody's uh, performance or in terms of high or low, that all would be qualitative. But data like people's marks and height and weight and all that, they are quantitative. And quantitative data can be divided into two categories: interval and ratio. And of course, you can use all the statistical measures to measure quantitative data. You could use mean, median, mode, find the IQR and range and everything. We will be studying these as well in detail, because the idea is to first understand the data type and then apply these measures. So first, let's see what is interval data. So interval data is numeric data for which not only the order is known, but the exact difference between the values is also known. That is interval data. So an ideal example of this would be the Celsius temperature measure, where you can find out the difference between two Celsius temperatures. You can also find out if two Celsius temperatures are same or not. For example, if you have 12 degrees Celsius and 18 degrees Celsius, you can measure the difference between them to be 6 degrees Celsius. Also, like if you have 15.5 degrees Celsius and 21.5 degrees Celsius, you can measure the difference between them as well and say that it is the same as the difference between 12 and 18. And other examples of interval type data would be date or time, because if you look at it, you could give an interval for all this. Like you could say tomorrow the temperature is going to be between 35 and 37 degrees Celsius. Or you can come and meet me between 7 p.m. and 8 p.m. tomorrow. Or you can come and meet me from between 3rd of August and 15th of August anytime. So that's why, since you can specify the interval and you can find the difference between the two values of the interval, we call this as interval data. For interval data, you can perform all operations like addition and subtraction, all mathematical operations like that. You can also calculate the central tendency. The measures of central tendency are mean, median, and mode. Mean calculates the average. Median will find the middlemost value if you arrange everything in sorted order. And the mode will find the value that appears the most in your data. We will be seeing this in detail as well, central tendencies. So don't worry if you don't understand it right now. So that is what interval data is. And you can also calculate standard deviation, which is the square root of variance. And variance is nothing but a measure of how different each data point is from the average value. So how dispersed your data point is from the average value. That is your variance. And from variance, if you take a square root of variance, you can get the standard deviation of your data. Now, interval data do not have something called a true zero value. So for example, there is nothing called a zero temperature or no temperature. Hence, you can only do addition and subtraction for interval data, but multiplication is not possible, like division and multiplication, because there is no zero value. This means we can say that a temperature of 40 degrees is equal to 20 plus 20 degree, because we can do addition. But we cannot say that 40 degree means twice as hot as 20 degree. We can't say that, because there is no 0 degree, zero temperature or no temperature when we talk about interval kind of data. So we cannot say this, but we can say this. Okay. Let's talk about ratio data. So ratio data represents numeric data for which exact value can be measured. Okay. For example, and like in interval data, we do not have absolute zero, but in ratio data, we do have absolute zero. So you can do everything. You can do addition, subtraction, multiplication, division, and also find central tendencies like mean, median, mode, standard deviation, or variance. Some examples of this would be height and weight and age of different people, their salaries. All these are ratio data. So to summarize, We can have attributes which are qualitative or categorical, or quantitative or numeric. And qualitative attributes can be nominal or ordinal, and quantitative attributes can be interval type or ratio type. Other than this, you can also have two other types, which are discrete attributes, which can assume a finite or countably infinite number of values, such as roll number, street number, PIN code. All these can have some countable value. So those are all discrete. And a special type of discrete attribute can assume only two values. They are called binary, like tossing a coin and you get only two outcomes. That is binary attribute. Examples are male, female, positive, negative, yes or no. Okay. And the last ones are continuous attributes, which can assume any possible value which is a real number. So, for example, you could have length of a person, height of a person, weight, price, because they can have any value. Height can be 160.1, it can be 160.12, 123. You could make it as accurate as you like. So those are continuous attributes. And that's it for this video. I'll see you in the next one. Thank you for watching.